Le son.
Ça ne fait pas dans les 5 minutes?
Non.
Okay.
Attends.
So, okay, my paper in 20 seconds. So. Amazing, you are amazing. Professor. Okay. So, yes, thank you for introducing myself. Okay, so I will talk about a paper that we did with our my colleague in Grenoble in the context of collision between France and Austria. Okay, on multi-element protocol for instability application test collection. So in fact, we are talking here about a collection which is COVID, so in the session about medical, but in fact, I mean, we just run this experiment on this collection. That's why we are medical field here, but I'm really applied to. Okay, so what we wanted to study here is what means stability, but the stability of ranking of systems on multiple test collections to check, in fact, what variation between collections are more impactful regarding this ranking of systems, which is simple. So, for instance, we use the identity as default on the Terrier or Kubernetes, and then direct smoothing model, and then on one collection is BL25 above, for instance, for NAT, better than direct or reverse or reverse ultimately. But this is that we're studying here. So, okay, for the idea that we follow for this is that we use one test collection, and let's start one test collection, and we create multiple pairs of sub-collections, okay, within this big collection. And we study the stability of the ranking of the systems on these pairs. Okay, so that's what it's important. Okay, that's a little more difficult, so a lot of text here, but mainly what we are studying is that between these pairs of collections, let's call them T2 and T2, we will study if the systems are before the systems are ranked so in the same order of that. To do that, we can split in fact the collection according to several elements, let's say this. For instance, on the document progress, on the query, on the relevance assessment also, we can split according to the relevance assessment. And to evaluate the overlap, the amount of overlap that we use a classical and simple way to compute the overlap to test collections, or to sub-test collections. And what we do with this, in fact, if we want to assess that the ranking of system is the same, probably that the information flow models are in the same order according to the evaluation measurements. And to assess this, we do not do this only on one split for a given overlap. We do this on a given set of splits here, which in our case is 50 splits. So we test on the predictive collection. Oh yes, we use the union of the rounds of PredCovid because if you are aware of, PredCovid is provided as a set of rounds. What we did is that we make the union of all the document and assessment and so on and so on and so on to do this kind of stuff. Maybe I will have a question about this later, but okay, I stop here. Then we test 10 IR models, non-neural ones, using Python. So we use for each of these models, we use the different ones. So for example, 25 and so on. So as I said before, we generate 50 pairs for each overlap value. We generate 50 pairs of sub-corpus. And to evaluate the fact that the ranking is the same or not, we use a simple thing, which is a Pendatto coefficient, which assess in fact to which level two rankings are the same or not, knowing that we have exactly the same elements in the two lists. So what we did is that we generate splits according to topics, sorry, okay, whatever. Documents, ED, topics, issue, assessment, or A, and positive assessment, because we said, okay, why not test only the overall positive assessment on the oh, yes, that's a big deal. So, okay, everything is interesting, but okay, we look only at this one because I only 41 minutes left, maybe. Focusing, for instance, on the, okay, top right, oh, already? Sure, thank you. Focusing only on the color, for instance, what we see, I will go very fast, as you know, when you want to push the button, maybe. Yeah, it's here. Okay, for instance, these dots here indicate that for the bitrate evaluation measure, when we have, let's say, 5% of overlap between the two subcohorts, we have only, let's say, 15 or 17 probability of 17% of chances to have the same ranking between our 10 systems that we or models to use in the collections. So maybe that for the topics, we get a stability when we have, I mean, stability in the same ranking of systems, only when we have a large overlap, which is not the case when we are focusing on documents. For instance, what we see here is that in the subcollection that we generate, even when we have a 5% of overlap, we have mainly one, I mean, the probability is 1 to have exactly the same ranking of system according to MAP. So next, okay, so I jump on this one. That's a kind of different way to present the results again. On this. So, okay, what do we present here? What did we present? We propose a protocol which is very easy to define, real, I mean, to make this run on every test collection. And in fact, we saw, which is not brand new, let's say this, because we know from other papers of other works, from Canulas, Robertson, Sanderson, and others, that we know that the thing will not be the same, but we find out specifically that the topics, when there is a small amount of topics, we have a big vulnerability of this, of the ranking of system. Which means that for me, but for me, I don't know, but for people that we hear me, is that we have to be very careful when, for instance, we try to optimize systems according to whatever we use for validation of single different topics. Then we have to be very careful because we may not we may not optimize the properly. So for future, of course, we will try to use it on other test collection to study several elements taken together, which means that in our case we use on one side document, on the other side topics, on the other side relevant assessments, and we will study the variation of relevant overlaps of elements taken together. And of course, we need to only focus on the overlap, which is only, let's say, equality of documents or equality of topics. We have to have overlap which are quite more refined and more meaningful. Let's say this. Okay, that's I'm finished. I have 2 questions. Yes, yes.
Which one must be rejected because it's probably poorly system? Which one?
But the best or the worst? What are you?
Both.
No, I think that MAP is the most simple, but we know that MAP is the most simple anyway. But it's going to be deeper for analytics. But let's see.
No question from the floor. Let's take the
Okay, let's come to the last thematic session of this morning, which deals with automatic labeling and modulation extraction. We will have three papers from three parts from Brazil, from Spain, and from Lyon. And we begin with Spain? Yeah. Okay, so
good morning, everyone. I am Prof. Gavin. We're presenting our work's program models for automatic keywords aligning of scientific documents. This work emerges because several IR tasks, such as faceted search, document expansion, query expansions, benefit a lot from documents having suitable keywords. Having this in mind, most models that address this task do it by merely extracting keywords from the given text. This means that creativity is not a feature of these models, but we think that it is really important here. Creativity in this context stands for the ability of the models to generate keywords that are not in given text. Having this in mind, we propose using a text-to-text model in order to address this problem. The task we are addressing is the automatic keyword labeling task, and the main goal of this task is to provide a set of short phrases for words that properly represent a document. Embedded rank is one of the most known models in automatic keyword extraction, and it works as follows. First, it extracts words or short phrases from text. Then it represents both the phrases extracted and the document as embeddings. And finally, it ranks the phrases based on the embedding similarity with the document they belong to. Along with this model, authors present an adaptation which makes use of maximal marginal relevance in order to increase key phrase diversity. For our proposal, as we said before, we use a text-to-text model. In particular, we use text-to-text transformer. T5 is one of the most popular models in NLP nowadays. And T5 is a unified framework that aims to convert all text-based language problems into a text-to-text format. As we can see in the image below, it already works on a wide variety of tasks, such as sentence translation, sentence summarization, or sentence similarity. For our proposal, we will model named T5 keywords. This model takes advantage of T5 text generation capacities in order to provide a set of keywords that properly represent the document. Using a text-to-text model like embedded rank gives us the possibility of generating keywords that are not in input text, giving the chance of building creative models. The image below is the result of fine-tuning T5 with a set of abstract and keywords, being the abstract the input and the keywords the labels. As we can see, the result is a model which receives abstracts as inputs, and it generates keywords that should represent the document the abstract belongs to. In order to evaluate the model, we use two methodologies. The first one is a classic offline evaluation, where we perform three experiments. The first one uses splits of inspect for both training and testing. The second one follows the same approximation, but using the US dataset. And for the last experiment, we use MAG dataset for training and a split of the CDS 2016 dataset for testing. We compute three metrics: precision recall and one score at 5, 10, and 15, and we compare our model against three baselines, which are three variations of the embedded rank model. For the online evaluation, we will only use the model trained on the MAG dataset, and we will only use the CDS 2016 dataset for inference. We compute two metrics: the assessor's mean score, and also agreement metric like Cohen scatter. We will only compare model against one baseline this time, which is embedded rank base model. As we may see in this table, our model performs embedded rank in terms of precision recall and F1 score in two of the three experiments. In particular, we perform better when not switching between domains in training and testing. While in the last experiment, where it's between training and testing, we perform much worse. In order to perform the user-based evaluation, we select 250 papers from the 2016 CBS dataset, and we provide each of the 4 assessors with 100 papers, being 50 all the same for all of them, in order to later compute the agreement between them, and the other 50 different for all of them. We provide assessors with a web application where they could read the papers, titles, and abstracts, and they have to rank between 0 and 3 each of the keywords shown to them. And the matching between each of the keywords and its meaning and the label shown to the assessors was as follows: 0 for inappropriate, 1 for somewhat related, 2 for reasonable, and 3 for very good. Here we can see the results of the user-based evaluation. As we may see, our model tends to hallucinate disease-producing keywords that are not related to the input document when switching between datasets. We can also see here the problems of classic evaluation when evaluating the models, as the difference between a meta brand and our model here is much bigger than the one shown on the offline evaluation. We also performed the pairwise intercessor agreement study in order to compute the concordance rate between each pair of assessors. We can see here that the agreement is high enough. Maybe if we ignore assessor 2, to say that our user-based evaluation results can be adequately considered. Recapping what we have seen in the last slides, we can say that our model performs a better round in the offline evaluation in 2 of the 3 experiments. We can also see that our model tends to hallucinate when switching between domains, and also see that our model performs much better when using splits of the same domain when for training and testing. Wrapping up the presentation, we will present the conclusions we started from our work. First of all, we explored the potential of a framework like T5 in the automatic keyword labeling task. We get improvements over a former state-of-the-art method like Bedrock. We showed the problems that energy models may have when switching between domains in training and testing, and we can also see the problems of classic datasets when evaluating creative models. This is all, and thank you so much for your attention, and we can start with the questions.
So T5 is a sequence model, right? Now, that of selecting keywords is not a sequence solution. So basically, the keywords are the set. So the selection of the ith keyword doesn't depend on the selection of the I-1 keyword. So I was wondering, like, if in your training examples, if you can permute all possible ways of selecting the keywords, like if you have got 3 different keywords, like you have got 6 different combinations of them, right? And if you throw that into your training process, would you get better results?
That's like we are working on as for future work, and we are exploring how it results in the evaluation, but we don't include that in the work I presented now. But it is a nice point, as it may include as the results of the model. Yeah.
Maybe one more question. So when you asked the assessors to select the keywords,
yeah.
So what were the guidelines that you mentioned? So when keywords, defining keywords is limited, right? I mean, the keywords with respect to what? I mean, do you want to search on that paper, or do you want to summarize that paper? So it depends on the interpretation of the downstream jobs. When you define the word keywords.
Yeah, I mean, yeah, the guidelines is that the keyword should represent the document's content. It should, like in a paper, was the same thing there. Yeah.
it's a big issue. You write and for what? Any more question? I have plenty of questions, but I will just one. What is your definition of unseen keyword?
Sorry.
What is your definition of unseen keyword?
Aggregate keyword, you mean? Yes, unseen keyword is a keyword that does not appear in the input text. You give to the model in order to.
Yes, but for example, if you take information retriever
Yeah.
as a keyword, in the text to retrieve information, do you consider that as a keyword or not?
I think I don't understand the question very good, so you can explain.
It's just a definition of unseen keyword. For example, about information description.
Yeah.
So it could be a keyword that doesn't have like this in text.
Yeah.
It could be a variant.
Yeah.
For example, to retrieve information. So it's a kind of occurrence as a keyword, but it's not the same.
Yeah.
So
Yeah.
what do you consider? Is
Okay.
it an unseen or not unseen?
It's unseen in that case. We only use some mechanisms with the objective of lexical changes, but not if you, for example, the example you made, that is not considered yet. Thank you.
So, our second paper, for you. Vas-y.
Sorry.
Good morning, everyone. I'm Alexandre, and I'm a PhD student from Brazil, and I'm in a research internship at the Art Lab in Toulouse, and I'm going to present first work I did with this in this internship, this joint work with the researchers of the Art Lab. So the title of the work is Exploring expert and mixed data augmentation in rhetorical role labeling of Indian legal settings. So the task that the task is to assign semantic roles to the semantic function of the sentence. So the idea is to identify the sentences in documents from judgments and to assign a role or a label for each sentence. These roles are specific from the legal domain. For example, sentencing for an argument, for facts, for institute or law. So the idea is it's simple. The idea of the test. We aim to apply to exploit the deep learning models, state of art, deep learning models in this sense. So BERT is one of these state of. And also there is a sentence BERT or BERT. BERT was proposed to produce better sentence embeddings, but from the hidden BERT hidden states. We exploited SBERT in order to generate the semantic embeddings, and also we exploit the mix-up method to generate augmented data. So the mix-up is the data augmentation method, it's agnostic to the nature of the data of the application. It can be applied in data from image, from text, because the method it's applied on the next vectors, not on original input data. Also, we use Mixup to generate synthetic vectors, and we use these vectors and these semantic vectors to train classifiers. Later, we evaluated the models, but here I have the detail of the experience, or the set is the data set comprised judgments from the Indian Supreme Court. There are 7 rhetorical labels. As guidelines, we set 2 guidelines, one which we have IDF vectors and one with expert vectors. And we evaluated 9 classifiers, 8 class machine learning classifiers. We evaluated 26 models. And we sought to answer these research questions from our experience. If the state-of-art models pre-trained with general domain data, domain text, they are able to produce useful representations from this text specific for the legal domain. And if the data, the algorithmic data generated by this method is able to improve the models. This table we have the results of the baseline models evaluated by the FU score. That's the NLP method. It's the integrated perception. Achieve the best scores in both feature sets. And the best performance was with the lexical features, the IDF features. And here we have the results of our proposal of exploit the mixed data with the expert vectors. With this argumentation to exploit just 2 classifiers because of the limitations of the library, we had to implement these classifiers, and we exploit just these 2. In the best, again, regarding F1, best score was with the NLP model. And it was a score. The best score considering also the baselines. There are 4 lines for each model, because there is a hyperparameter of the mix-up method. It's the alpha value. So we exploit this 4 values for alpha, and so we progress for augmented data feature sets. Conclusions. Our results show a small difference between the lexical and semantic features, with slight better performance of the lexical model. We compare just lexical and semantic features. And our proposal, we exploit Mixup, was able to boost the semantic models and to overcome the baselines. For future work, that it's already happening. We plan to exploit pre-trained models on legal documents, legal words, for example. This is, and I think so much was very quickly because it's just 5 minutes presentation. Thank you very much.
confusions and what are the roles?
Unfortunately, I didn't put in the slide, in the paper, there is a table showing the scores by label. The data set is high balancing. I don't know exactly what were the worst labels, but I remember there are 3 labels with small quantities, and one of these labels, the model's performance good, and for the others, there was a lot of confusion between these two labels. I listened. I really don't remember. For example, there is a label, describe effects. It's a label with big number of occurrences. For this label, there wasn't occurrence. I just remember. There was a label. I took notes. There are 2 labels: rolling by our part and rolling by present part. Because it's a high court, usually the case are to be reviewed by Supreme Court, and there's a decision for a minor court, and so there's sentence that state that inform the decisions of the minor court and the sentence with this decision of the. There was a lot of confusion between these two labels.
Last question?
You treat this as a central suspension problem, right?
Yes.
So that if you look at the document, so if you look at the sentences, so there could be cracks in one particular section of the document, and there could be documents following that. So you know that if the previous sentence is back, then there is a high probability that the next sentence will also be back. Right? So these are not really independent.
Yes.
Suspension problems.
Yes, you're right. It's in our query work, what we are exploring the position of the sentence, because it's science.
And yeah, and one thing is that there's plenty of repeated things. I mean, I have looked at a few documents. So some things are stated as facts, and the same things are again stated as arguments. So maybe with a slight modification of sentence structure or something. How do you deal with this kind of ambiguity?
I didn't try to do this because the following test, I'm focusing on facts. So I changed the data set to work just with facts, and the other rules I consider all of these issues. And I'm not working in this kind of embedded intelligence. Not yet. But for now, just the positions.
We cannot disclose the chat, as you are saying, the chat is the chat. We can add disclose features.
Okay.
And as you only read,
Thank you.
okay, let me go to
I don't have the exact number, but the sequences are not very long, so it's not a problem for birds. But it has the limit of the size of the sequence, but it's not the sequences are not long. Yes, it's the data set.
Doesn't mean that he has these sentences.
Thank you very much.
So the last person is supposed to be online.
Yep. Can you, Corentin, you can switch
Yeah.
your mic off. Can you hear us?
Yes. Yes, I can.
You, yes, but the circle people. Josiane.
Nous sommes là. We are here.
Okay, can you give Corentin the right to share his screen, please?
Thank you.
Oui, je sais pas où il est.
À côté de son nom, il faut cliquer sur plus, cliquer sur les participants.
Le micro risque de faire des interférences. So you can share your screen probably? No?
Not me.
It's Corentin who will share his screen, not me. I have the right, but it's Corentin who should share the screen.
Sorry about that.
Okay,
Yes, you should be able now.
okay, Corentin, tu peux.
Thank you.
Circle is still okay.
Okay, so does everyone see the screen and can hear me?
Yeah.
Yeah.
Okay, so I will begin. Hello, everyone. Thank you for attending this presentation. My name is Corentin Forler. I am a master's student in computer science in INSA Lyon, and I will present my article, Studies on Interactive Event Detection and Labeling from Timestamp Text, co-written with Helle Degey-Sigmond. So in our paper, we propose a system for unsupervised event detection, interactive visualization, and automatic labeling. Our work is based on MABED by Adrien Gil and Cécile Favre, and its main implementation called PyMABED, which is a web application. We have identified 4 aspects that limited the practical use of MABED for our purposes. So the first limitation of the original MABED is the need to specify the number of events to detect beforehand. Also, an event is described by a set of keywords, which can be difficult to understand for the users without adequate context. Another limitation is that the original web interface was not fully interactive. So the parameters of the event detection were not could not be changed by the users. And finally, MABED is specialized to detect events in a set of tweets. So we wanted to run it on other sources like news articles. So we had to change it. So given these limitations, our work mostly focused on adapting MABED to an interactive use. So our system provides a simple interface to adjust the number of events to detect and some other parameters. We also, in our use case, some parameters never changed. So we could use a cache system to increase the response time of the interactive system. Also, MABED computes its result in multiple steps, which meant it was possible to cache intermediate results and even pre-compute some results. And we also extended the method to detect events from any text corpus, any timestamp text corpus, not just tweets. But we lost some of the advantages of MABED. And finally, we also implemented the labeling approach by selecting the most representative text within a document. So in Mabed, events are described by keywords. So we want to label events with full documents instead, which is done by finding relevant documents in the dataset. The idea is to give a full document as a label to an event instead of just keywords. So we designed four labeling methods. The first one is a simple keyword counting. Second one, occurrence-based keyword counting. Third one, a method based on the OKP BM25 ranking function. And finally, word embedding, text embedding based ranking function. And on this table, you can see the results of those four methods and four different subjective metrics. The details are in our paper. So here on this picture, you can see the full interface, graphical interface used to evaluate the ranking methods, and it's kind of the experimental setup in a way. So on the left are keywords in blue and brown for primary and secondary keywords. And on the bottom left is the controls, the buttons used by the evaluators to rank and reject the three different subjective labels for a given event. And the right is the impact histogram shown to help the users understand when in time was a given event happened. In our paper, we present our ongoing work on adapting and optimizing Mabed for an interactive event visualization context. We have tested several event labeling method, and we selected a simple one, the simple keyword counting, which gave also the best results. And we also made the computations faster by using cache system. This is important for interactivity. And we improved this interactivity by adding a simple user interface to change some of the parameters. And finally, we also extended Mabed to work on other text sources, such as news articles. And we are currently working on the automatic estimation of the number of events, as well as the dynamic estimation of some other parameters. That's it. Thank you for listening. And if you have any questions, I'm happy to respond to them.
Okay. Are there any questions? The assistants? Okay, there is one.
Okay.
I don't know how to. Yeah, perhaps Jacques come because I don't know how it works. So
yeah, thank you.
It's a surprise to see that the simple keywords is just working the best. Do you have an explanation?
Yeah, so I don't know exactly. We see that the first three ones gave pretty correct results. Also on the first. So there were three suggested labels given by the algorithm, and for the evaluators to kind of rank to know which one of the method was best. Anyways, but only the first two columns matter for the end result. So I think,
or the poor result with the text embedding.
Yeah, I think it's because it was the technique we used was not good enough. I used some averaging, so I computed an average vector for a full document, and I think that's what.
Maybe we can.
Because when I compute the average, then all the synonyms and the similar words have kind of similar vectors. And when I compare them to the keywords, I find a lot of matches, I think. I don't exactly know why.
Thank you.
Okay, thank you. Just to complete the question of Jacques, in your keyword counting, do you have a lot of name entities, or is it common nouns?
It's just keywords. So it can be anything that Mabed detects. So I think I can have here an example. So here in this example, Mabed detect India, which is not a common word. It's an entity, but there is no entity detection, and everything is keyword based.
Yeah, but you detect Delhi, but not New Delhi. Huh? So...
Yeah, exactly. That's what are the drawbacks of the method.
Okay, so any question more? Okay, so let's thank our speaker and close the session.
Thank you.
Thank you. So I have some announcements. So maybe can I have the microphone, please? Can I have the microphone? Or should I speak loud? Okay, I'm going to speak loud. Ah oui, je peux continuer. Oui, mais ça rentre là? Si. Oui. Merci. So just a few announcements. Okay, so about today, so first of all, I would like to tell you, for the one who didn't pick up the invoice, we have the invoices, so you may need them for your refunding. So we have that in the center. We have also certificate of attendance. Some of you need both, depending on the university and the places. Regarding the buses, there were some fake news saying that the bus is stopping anymore to the center. Indeed, that was just yesterday. So today they are back, but on a very new road. So it was because they were redoing the road that the buses stopped yesterday at the center. So you have buses stop. You can see them when you walk back. So that will be a practice thing. So you walk back and you will see there is a zebra on the road just in front of the center. I mean, you have to be on the road on the same side as the center to take the bus to Toulouse. So the timetable is on the website. You have the timetable on PDF, but you also have some apps that tell you what is the next, but you know they are not very often, so you rather check the timetable waiting. Remember that they don't stop at any stop, specifically that one, because there is not often people taking a bus there, so you have to tell them. Same for going out. If you stop at Hippodrome in time, you have to tell them, because there is no, I mean, it's not that usual. So that was general information regarding the bus. But so this morning we had these sessions with the keynote recommendation and search, the medical information access, and the automatic labeling and relation extraction. We didn't have my work in 120 seconds. We will do that. We postpone that to this afternoon, so it will be just before the demo and the posters themselves. So that will be in the room that we used to be in the center. And by the way, we are going for lunch now, but this afternoon, you know that we go for a visit of the cathedral. The cathedral is closed, is 20-minute walk to Lombes, but no, we have checked. With Google, we walk 5 kilometers per hour. We are more than that. We walk faster than that, right? So you can also take a bus. So again, we are lucky because there is a bus at, so I put 1:35. In fact, the bus is supposed to be there 43, but it can be a little bit in advance, so it's better to be there some minutes before. So there is a bus, there is only one stop. So, and again, you have to tell the driver, okay, I want to stop to Lombes, the city, or Lombes, but this is the next stop. So you can tell them, I want to stop the next stop, or you can go walking. So there will be a guided visit to the cathedral. It will be in French because the person doesn't speak French, English, but there will be also some documents, and the cathedral is worth to visit, even if in the place, even if you don't listen to the guide. For the guide tour, there is a fee of €4. This is not for the person. The person is just a benevolent. A volunteer, sorry. She is a volunteer, but this is to help for the maintenance of the building. Then we will go back to the center. We have to be at 4 p.m. at the center. So we have to leave right after the visit if we go walking. For the one who don't want to walk, there will be a bus back at 4:30. Again, be careful to say to the driver that we want to stop. So the bus stop is there, very visible in that case, that one. Of course, if you take the bus, you are going to be a little late. So it's better maybe if you can walk. So we will have the booster first, plus then the poster and the demo session. So the booster will be like we planned this morning normally, and there will be a vote. So you will be asked, and we are going to send you an email. You are going to ask for. We are going to ask for a vote for the poster that you like the most. There will be a job offer list. It's a PowerPoint. I emailed to most of you as well. I think you should have received an email if you have for the seniors. If you have a position, it is still time also to send us this so that we can add that to the PowerPoint. It's either postdoc or PhDs, so you can be aware of that, and we will post that also on the website. An informal discussion on the future of the conferences, so it can be also a possibility to discuss about that. And we will have the dinner. I put that it will be at 7:30. We have to be rather on time this time, right? Because of the concert, which is planned at 9. I will check if it's 9 sharp. I will ask with I don't believe that, but okay. So enjoy your lunch. And the closing session, I think that we will have the closing session at 7 as well, because then the day after, some people are going to.
Du typical.
Oui. Merci beaucoup.
T'as besoin d'aide?
Non, parce que j'ai la voiture. Enfin, si tu veux déranger, c'est bienvenu.
Qu'est-ce que...
The pointer.
Oui,